let's say I'm going to kick the football with a speed of 20 meters per second, and I'm going to kick it at an angle of 15 degrees to the ground. So what I want to know is, how long is my football in the air? What is the range of my football? And what is the maximum height reached by my football? So let's go back and look at our picture of that situation one more time. This is our projectile. I already split this up. I gave it an initial speed of 20, right? This is 20 meters per second. But I already split it up into its x and y parts. I know for the y motion, my initial speed is 5.3, and for the x motion, my initial speed is 19.3. Oh, I'm sorry, this is 5.2. 5.2 and 19.3. So, to figure out the x direction, or to figure out the range of my projectile, I want to figure out my change in x. How far did the projectile go? So in the x direction, we only have this expression we can use. Velocity in the x direction equals change in x over time. I know my change in x, but I don't know my time. So, a good way to solve for the time a projectile is in the air is to figure out how long it takes my projectile to get to the top, and then just multiply by 2. So let's look at our y direction. The only thing that's going to affect how long the projectile takes to get to the top is going to be my y speed. So I have Vyi equals 5.2. I want to know the time for when my projectile gets to the top of its path, or when the final speed at the top is 0. And I know that in the y direction it's accelerating at this rate. So I can say final speed equals initial speed plus a times t. So for this is 0. Initial speed here is going to be 5.2. This is 10, and this is t. So it looks like, when I do my math, 5.2 equals 10 times t, so time is going to be 0.52 seconds. Alright, so now I know my time. Let's come back up here to our horizontal motion. So now I know my time, and I know my speed in the x direction, so I can figure out what my distance is in my x direction. So the change in x is going to be equal to 19.3 times the time I just found, which is 0.52. And when I do that, I figure out that the change in x for my projectile is 10 meters. Alright, I got half of the problem. Or, yeah. Because they also wanted to know how long the projectile is in the air. So I figured out how long it took the projectile to go halfway. So now I'm just going to multiply 0.52 by 2, and that gets me 1.04 seconds is the time for my projectile. Now the last thing is to figure out my change in y. Alright, so the height of the projectile happens when my final velocity in the y direction is 0. So let's look at our givens again. 5.2, and a is again 10 meters per second squared. Alright, so we can use this expression, Vfy squared equals Vyi squared plus 2 times a times change in y. That will help us to figure out what our change in y is. Alright, so 5.2 squared is going to give us 27.04. Oops, 27.04. And this is 0, so that just goes away. So that's equal to 20 times change in y. So 27.04 divided by 20, that gives me a height of 1.34 meters. I'm a terrible football kicker, apparently. That's not very high at all. All right. So what I want for you guys to do now is try on your own, if you have your textbook or if you can get online or not. Actually, don't do one from your textbook. I'm going to give you guys one to try. So let's say there's a kangaroo, and we're going to keep with the kangaroo theme of the last test. So let's say there's a kangaroo, and the kangaroo jumps, and when he jumps, it takes him 0.8 seconds to jump a distance that is 2.4 meters away. Now let's say he makes this jump at an angle of 33 degrees to the ground. So let's draw a picture of our kangaroo. I'm not going to draw a kangaroo because I cannot draw a kangaroo. Let's say this is our jump. He's jumping this distance, which is his change in x, which is 2.4 meters. And the angle he's making that jump at is 33 degrees. And I'm telling you that it takes the kangaroo 0.8 seconds to make this jump. I want you guys to find for me what a couple of values for this problem. What is the actual initial speed of the kangaroo? I don't want to know what is his horizontal speed or what is his vertical speed. I want to know what his actual speed is. And also, what is the maximum height reached by the kangaroo? So try to do this one on your own, and we will talk about the answers tomorrow. And here are the equations again if you didn't copy them down the first time. And have a good night. See you guys later.